All right. I don't think it's echoing. For 2.1, chapter 2, we're starting graphing on coordinate planes. You remember this? Yes? Okay, let's just review. Which quadrant is the first one? That one? Yes, that is correct. Then counting, do we go down or to the left? Left. So 1, 2, 3, 4. Very good. All right. Now for these coordinates over here, is it yx or xy? It's xy. And so for -4, do we go left 4 or down 4? Left. X is left and right. So we go, whoa! We go left 4 and then which way 8?
1, 2, 3, 4, 1, 2, 3.
Up. So left 4, up 8. So that is point A. So do that one.
36.
Okay, go ahead and do all the other ones. It's like
Already on.
you're already on it.
Nope, not really.
B's pretty hard. I don't know what B is. Oh, it's just right there, dag in the middle. Oh yeah, got a label.
Yeah. So you've got 3 points in quadrant 2, 1 in quadrant 1. And what is the official name for that center point?
Origin.
Origin. That's the origin. It was close.
Origin.
Origin, right there. All right. Now, when we graph things like this, we call them relations because they're grouped together. They have some sort of relationship. The official thing here, it's a set of pairs of input and output values.
Oh shoot. Forgot my glasses.
Okay, for input and output, which one is Y, which one is X? Input, you are correct, is X. Output is Y. So which one is the independent one? X. It's the one that we start out with. You can think about input and independent go together. Okay, and then the output is our dependent because that one always depends on whatever X is. All right. Let's see. We can write a relation as an ordered pair and graph it on the coordinate plane. Okay, that makes sense. So this is just showing you that these are a relation. They're in brackets, so they go together. They have some sort of relationship. Just very quickly go ahead and graph those as well. So left 2, up 4, right 3, down 2, left 1, right 1, up 5.
It's like a trapezoid. You're a crack artist.
For relations, we have domain and range. One is X, one is Y. Which one's which? X is domain. Y is range. Do y'all have like a way to remember that? It's just in your head? Okay, if it gets confusing, think about alphabetical order. Okay, X comes before Y, D comes before R. So X goes with the D, Y goes with the R. So domain is the set of all inputs. So it means the X coordinates. That blank is kind of small. So for the one we just graphed, the domain would be the -2, 3, -1,
It's out.
and 1. So then the range is the output, set of all outputs, which are the y coordinates.
Y coordinates.
So in that one, 4, -2, 0, and 5 would be the range. So let's practice finding domain and range, and we're going to practice from something that's already graphed. So for domain, it's x, which is, we know, is this horizontal axis. I recommend for domain, look from left to right, and we'll just list out everything we see. And then for range, we're going to look from bottom to top. Okay, that's just my suggestion for all year long. That'll be helpful. So domain, not domains.
Domain.
For domain, we're going to use brackets to put these in a set. So look from left to right. So as we move left, what's the first value we hit with a dot there? -4. So we write that down. Now keep going, and we hit, there's the next dot,
That's -3.
-3, then -2, what? 2, and 3. All right, so we have 5 values in our domain. All right, let's do range. So for range, start at the bottom and go up. So what's the first value we hit with that dot?
That's 4.
-4. What's the next one?
That's -2.
-2.
And then the next is a 2.
2.
And then 4.
Okay, now there are 2 values at 4, 2 points at 4. Just write it once. Okay, if it's in there, it's in there. You only got to write it once. So though we have 5 domain values, we have 4 range values. Any questions over this? Okay. Now for the back, we're gonna look at a different way to look at coordinates. We've looked at them just listed out. We've looked at them on the graph. Now we're gonna use a mapping diagram. So we're gonna label these 2 circles. The first one will be domain, which is X. The next one will be range, which is Y. All right. So first thing, just go through and list the values that go in each. So for domain, what are our X values? -1, 3, -5, and 3. We already wrote 3. Don't write it again. All right, what are our Y values?
-5. -2, -6, -2. -2, -10, -2.
Yeah, you can put them in order if you want. Just remember, if it's there twice, only write it once. Now, draw arrows connecting the different pairs. So like -1 goes with -2. Then 3 goes with 6. Then -5 goes with -10. And 3 again goes with 2. So you should be able to go, all right, let's stop with the weird voices. They're distracting. You should be able to go from the ordered pairs to this thing, or if you start with this, you should be able to get back to the ordered pairs by looking at it. Could you do that? You could get 1, -2, 3, 6, 3, 2, -5, 10. All right. Now we're going to use this in identifying functions. Is the word function familiar? And algebra and math. A function is a relation in which each element of the, I don't want to write it wrong, of the domain is paired with exactly one element of the range. Now it's very specific about that. One of the domain, or the domain is paired with exactly one of the range. Okay, another way to say that would be only one y for every x. Only one y for every x. Now, we say only one y for every x, but there can be more than one x for every y. It's a little confusing, but this one, it doesn't matter what it is. We're not worried about it, but we're worried about that there's only one y for every x. So let's look at these. We're going to look at a mapping first. Okay, in this first one, just look, are there any double arrows? Like two arrows going to one number? Yes, right here, right? Okay, this is our area that we need to look at. There are two x's for that one y. Does that matter for whether it's a function or not? No, that goes along with this statement down here. There can be more than one x for every y. So if there's two arrows at a y, that's fine. Okay, so this is, yes, it's a function.
Yes.
Two arrows at a y is okay. So check mark, we're good there. Now let's look at the next one. We've got, do we have double arrows anywhere? Yes, we've got double arrows here. Okay, that's two arrows at a y. Is that okay? Yes, that one is okay. But look over here. Let me get a new color. Okay, this 0 thing, it has two arrows. It's an x. That is not okay. So this is no, it's not a function.
Why? Because there can't be two y.
There cannot be two y's for one x. Only one y for every x. Now, we are going to look at another way to determine whether it's a function or not. Okay, so if, honestly, the other way works better for me, but you can just kind of pick and choose. Before we do that, we're going to talk about the two different kinds of relations. So far, everything that we have graphed has been discrete, meaning there's just been points. They're not connected. Okay, the ones down below that are connected, those are called continuous. So you can write this in your own words or write whatever I write. So discrete is a collection of isolated points. Okay, it's just points. Continuous is an uninterrupted line or curve. Okay, so the continuous ones, those are the ones that you can draw completely without ever picking your pencil up. Discrete, you got to pick your pencil up. All right. Now back to figuring out if things are a function or not. Have y'all used the vertical line test before?
Yep.
Yes, I love the vertical line test. I like it way better than the mapping things, but different people think different ways. So the vertical line test says that if a vertical line, which vertical is that, left and right or up and down?
Up and down.
Up and down. So if a vertical line, meaning up and down like this, passes through at least 2 points on the graph, that means not a function. Because if that happens, that means that there were 2 y's for 1 x value. A, we can draw a vertical line and it hits twice, so that is not a function. B, let's see, I'm going to draw 1 line. Well, that only hit once. I can draw like thousands of lines, and it'll never hit more than once, so that means it's a function. Now C, okay, is this one discrete or continuous?
That one's
Discrete. It's just points. They're isolated. So we can go through, let's see, if I start there, it only hit once, that's okay. There, it only hit once, but right there it hits twice. Right there it hits twice. So, yes or no?
No.
No, not a function.
Just like that.
Okay, so the ones that are functions get their own special notation, which is what goes up in that star. Okay, so like B would be able to use this function notation. Anybody know what it looks like? Looks like F parentheses X close parentheses. It's supposed to be a normal F. That's just an accident. Okay? Now, you need to know that this is not multiplication. It's just a name. And sometimes they're going to multiply. Oh, dear.
Yeah, I'm having
I got off.
trouble here too.
Multiplication. Sometimes they're going to replace that X with other letters, depending on whatever the variable is. That's fine. Sometimes they'll replace it with a number. No matter what, that is still just a name. It is not multiplication. Okay, and the way you say it, the way you read it is f of x. If the variable we're using is a y or let's say an a, then we'd say f of a. Okay, but it's not multiplication. It's just a name. We good? Any questions? No? You need to stand up and turn 10 circles and sit back down so you're awake?
Probably.
Probably. All right, you've got homework, so work on that.